Hello, everybody. Good morning. Welcome to KVM Forum 2024. Happy to be back here in Brno. My name is Oliver Upton. If you don't know me, I co-maintain KVM ARM64 with Marc Sanger. So if you've been to a KVM Forum before, you know that usually Paolo is up here telling you all the stats and everything about contributions to KVM. Well, this year he asked me if I wanted to do it, and I said, sure, I'd be happy to. So if it goes well, great. But if it doesn't, then it's obviously Paolo's fault. So anyway, without further ado, let's get into the stats. Within the last year-ish of contributions since we last met, it was late 6.4 RC back when we had KVM Forum in 2023. Now 6.11 was just cut, and we're in the middle of the 6.12 merge window. There's been roughly 1,700 commits across all the architectures to KVM, 90 of which have been CC'd to stable, and about 20% of those have been self-test changes, which is actually a really good improvement to see on KVM, and something that's been holding for a while is getting a lot more tests upstream, people actually testing their code. We kind of look at the trends over time, so kind of a sliding window of every 5 kernel releases throughout history. We've kind of been seeing a bit of a downward trend in terms of contribution on KVM, which is interesting, but I think we still have a lot of engagement with the community. And then if we look at contributions by employer, there's quite a bit from Google. But it's a little hard to make sense of this graph, of course. So I figured, you know what, why don't I pull out the human fire hose from the Google bar and put Sean in his own category. So I think this tells a lot clearer picture. Yes, Google is still one of the main contributors to KVM, but beyond that, we see Red Hat, and then all of the CPU vendors, as well as Amazon. So a very good spread of folks across all the different architectures. And then in terms of contributions by area, this is another place where we've been seeing changes in the trends. So if you remember from years past, this has been almost entirely x86 with a small spread across the other architectures. ARM64 has been catching up quite a bit. It's been getting at least a little bit more popular. And then beyond that, yeah, we see a good mix of self-tests and generic changes, which we can talk about here in a bit. So what's new? In terms of generic KVM code, we've landed initial support for guest memfd upstream, which is super exciting. This is a massive change for unblocking the confidential compute across the various architectures. And along with that, we have some additional changes like the ability to back mem slots with an FD, as well as a ioctl for describing memory attributes, so that way you can describe, for example, shared versus private memory. Although I'm quite certain that that'll see a lot more uses outside of just pure confidential compute. And then, of course, a bunch of fixlets and cleanups all around the shop. And then for ARM64, which I wouldn't be biased at all in terms of what has been happening on here, we've had a lot more work on nested virtualization on ARM64. So let's see, I think around in 2023, we got the initial set of patches in for nested virt, just in terms of core infrastructure, not fully supporting the feature. Since last, we now have support for reflecting traps into the L1 hypervisor, initial shadow MMU support, and then rounding out the CPU features that are exposed to the guest hypervisor. One of the other topics that we talked about last year was configuration of the CPU feature set through the ID registers. So we've got a lot more infrastructure for this to effectively enforce that in KVM's trap configuration. We also support normal NC mappings for VFIO devices. So this is a really big thing for GPU device assignment. It's not quite right combining, but it gives you right combining properties that you like with GPUs. FFA support for the host and protected mode. So this is a big enabler for being able to run pKVM on any devices that are actually shipping, because there's quite a lot of services that live in secure world that you want to talk to. And then just a good mix of performance improvements to the MMU, eager page splitting for live migration, TLBI range, and then in the VGIC, the SGIs, so IPIs, and LPI routing. Switching over to x86, there's been a lot more work going into virtualizing CPU features. Big surprise. One of the biggest features that landed was SEV SMP support, so that's really exciting to see that. And then kind of as some of the learnings of how SEV has progressed on x86, we've had some cleanups and alignment on the UAPI for SEV and SEVES, kind of fixing a few mistakes here and there. And then one of the long-standing bugs that we've had for VMs on x86 is allowing the guests to discover what the max mappable GPA is inside of the VM, as opposed to what's the max physical address that's supported by hardware. So this was kind of an issue for things like firmware trying to set up PCI bars and wind up plopping something down outside of what KVM can map. So now with this new CPU ID interface, we can communicate to guest firmware where exactly it can lay things down. On top of that, there's an ioctl for pre-faulting the secondary MMU, which is super helpful for things like TDX, but it also can help with cold start latency for like non-protected VMs because you can get the whole stage 2 MMU pre-populated. And then a few hardware bugs. One that comes to mind as of recently was some changes to honor guest pat, and apparently, what is it, the box device on x86, when it starts seeing the UC on Cascade Lake and newer parts, the performance goes like completely down the drain. So we had to back that one out last minute in 6.11. So hopefully we can revisit that, but right now it seems like that's a hardware bug for sure. Looking at RISC-V, there's a ton more CPU features. It's more of the alphabet soup. I couldn't quite make sense of it, but there's things that are going on there. There is support for the new AIA IRQ chip in KVM, as well as virtualizing new SBI features. So SBI is like the firmware hypercall interface. So for things like stolen time, debug console, and then one of the other interesting things on RISC-V is PMU is actually you can interact with the PMU through the SBI interface. There's now support for PMU snapshotting as well as overflow interrupts. And then looking at the rest of the gang, on Long Arch, we actually picked up the Long Arch series, so we now have architecture support for Long Arch. That went in since last time. And then some new paravirtualizations around IPpies and Steal Time. PowerPC picked up a new nested hypercall ABI, as well as a set of bug fixes. And then on S390, we have support for paravirtualized crypto devices, as well as the secret ultravisor call interface for managing secrets in the ultravisor. And then looking at what's coming up next. So I think one of the biggest cleanups that Sean has been carrying recently has been cleaning up the way that we don't correctly manage non-ref counted pages inside of KVM. So this will be a big one for handing off GPU buffers to VMs. And then, of course, we have a lot more features that need to be built on top of guest MMFD. mmap support is a huge one, especially for the PKVM team. Getting huge page support, so some of these topics came up in Plumbers. Unmapping guest MMFD from the kernel, so unmapping from the direct map for speculative CPU bugs. And then also maybe some testing support for memory poisoning, so using maybe the memory attributes to mark PFNs as poisoned that are in guest MMFD. One of the other areas that we had talked about before was the Arch independent MMU. So this was very interesting. It was something that Google was pushing for, but some of the gas has come out of that. So kind of curious if there's still interest in the community for an architecture independent MMU. And then looking more at some of the CPU features, there's a lot of work going into a quote unquote pass-through PMU. And rather than having KVM act as a client of perf, allowing KVM to get direct access to the PMU counters to hand off to the guest. Be good to have a nice abstracted interface for perf and KVM here, so that way we can support this, across other architectures. A ton more TDX work to happen, both in KVM and all around the kernel. Maybe we can get nested virtualization support in for ARM64, which would be cool. And then a lot more work to be done on PKVM upstreaming. So some closing remarks. Just wanted to kind of look back again at where KVM Forum is. So this is our second year running as an independent conference. We've certainly grown quite a bit from last year. We have 2 full tracks, so it's great to have all of you here, and thank you for coming to attend. We're back here in Brno. It's a really cool city, which is fun to see, but hopefully we can plan out something different for next year. There's going to be a social event. It had been added to the calendar at I think last night. and there should have been an email that came from Eventbrite. So AWS is sponsoring that. It's tonight at 7:30. And then if you have any feedback for 2025 on ways that we can manage this better, how we can schedule this, location, timing, there's been some discussion about like how co-location might work. But if there's any feedback that will help you and your colleagues attend from your companies, then please do let us know at the committee. Then I did want to offer a big thanks to our sponsors. Without them, well, we wouldn't be able to do this. So thank you very much. And then also special thanks to the organizers for KVM Forum. So the Red Hat team here locally in Brno has been helping out a lot with getting the conference organized. And then on top of that, the SF Conservancy has managed QEMU's finances for the past 10-ish years, and they've now signed up to help KVM Forum with managing our finances. So we have a bit more adult supervision now, which is super helpful. So yeah, thank you to them. And thank you, Roseanne, from the accounting team over there. Also want to recognize the special work that SF Conservancy does for promoting the use and distribution of free software, as well as ensuring that companies honor the GPL. And that's it. Thank you.
All right. There we go. Okay. Are we ready? So just some introductions first. My name's Alex Benet. I'm a virtualization and emulation tech lead at Linaro. So that means in my day job, I spend most of my time working on QEMU, although I have been known to delve into the KVM code from time to time. And I also do a bit of a side in Vert.io. So in today's talk, I'm going to talk a little bit about the history of instrumentation and specifically how that's been done with QEMU and some various downstream forks. I'm going to give a brief overview of the TCG plugin infrastructure, talk about some of the new features that have been added in the last year or so, and then have a little bit of speculation about potential future directions that we might want to move in. So let's start looking at some of the downstream forks. So QEMU is actually a quite heavily forked project. There are a lot of downstream forks, and a lot of them exist because people are just wanting to implement a machine model and they're not particularly interested in upstreaming it, or quite often there's quite a lot of academic work that's done on downstream forks of QEMU. But I want to talk about some that have turned into their own specific projects. So the first one I'm going to mention is Unicorn. So Unicorn is basically what libtcg would be they've taken the TCG front